Hi, Steffen here. Do you carry out tests where your measuring object exhibits small deformations? Then this video will certainly help you in your evaluations. Let's go! There are many tests where only minor deformations occur. These can be, for example, structural tests in the aerospace or automotive industry. Very often, however, the warpage under thermal load is very interesting. For this purpose, components such as small electronic components, but also larger parts, are placed in ovens or climate chambers and loaded with temperature and temperature changes. A further application is the measurement of battery modules of electric cars. Here it is very interesting to see changes of the surface under different charging cycles. Let's look at the typical test here. Here you can see the test setup. We have the hood of the car inside a large oven. We measured with the Aramis system through a large window. After preparation of the test and starting the test, you can see here the behavior of the hood during the temperature load up to 190 degrees. Let's take a look to an evaluation. Here in this graph you can see the change of the temperature from 30 to nearly 200 degrees in the heating phase. We have a smaller cooling phase where the temperature falls very fast. When we take a look here in the left image, we can see a false color distribution of the displacement Z. Z means here a change perpendicular to the hood surface. And furthermore, we can nicely see that the largest displacement happens on the edges of the hood. Additionally, we created 4 points, and you can see the behavior of the points during the complete measurement in the lower right graph. As you have seen, the false color representation of the displacements already provides a good interpretation of the values. Since the deformations relative to the size of the objects are very small, the deformation is not seen with the naked eyes. However, this is desirable for a better interpretation, since, for example, bumps and dents are clearly better visible. I want to show you that little trick now inside the software. Let's take a look in the project itself. Here we can see the false color representation of the displacement set of the hood itself. Furthermore, in a diagram, we can see the temperature curve during the heating phase and also during the cooling phase. Let's take a look inside the data itself, and you can see that the largest deformation happens directly at the beginning of the cooling phase. We are here in the range of 1.5 millimeter on the corners, on the edges, and -1 millimeter here in the middle of the surface. So it's quite nice to see. But you can imagine, you can directly see it here, that the values of 1.5 millimeters and 1 millimeters are quite small in relation to the size of the hood. So it's relatively hard to interpret here some bumps and dents directly in the false color representation. But here we have another trick. We can create a so-called exaggerated representation. We will do so directly in the surface component analysis of the hood surface displacement Z direction. Just go to Edit Creation Parameter, and you can find directly here the exaggerated representation. When I click here, we have different possibilities. We can project onto the basic element. This is a standard setting in a quite normal evaluation. We can switch it to geometric element, but also to plane Z, plane Y, plane X. Here we have a curved surface, so it's a good idea to choose a geometric element. And you can directly see in a factor of 100, you can directly see this representation, and it's quite nice to see where the largest deformation appears directly in the geometry itself and not only on the false color representation. If you need some more information, just click the question mark and take a look inside our tech guide. Okay, when I'm pressing OK, now the dents and the bumps are much better visible. You can directly see here. And this is quite nice to see what happens with the geometry. It's a nice representation, and it's much better visible what happens during the cooling and heating phase here. One remark, especially in ovens and measurements through windows, the small noise may be a little bit larger than a quite normal measurement in a laboratory. But also this exaggerated representation will also magnify the noise. So it's always a good idea to set a filter. Take care, filters will influence the values itself, but for such a visual representation, it's sometimes a good idea to set a filter. I will show you the influences here. Edit creation parameter again. And we have here some filter setting. We set a filter here, but when I, for example, switch off the spatial filter, you can directly see the magnified noise. And yeah, this is what I normally not want for a visual representation, for a visual interpretation of bumps and dents. So we set it a filter here. In that case, the evaluation it's a little bit better to interpret. Summarized. In tests with small deformation, for example warpage of components under temperature load, it is often interesting to see not only the values as a false color representation, but also the change in shape of the component's geometry itself. To achieve this exaggerated representation is used, which can be activated directly in the surface component check. Since the very low measuring noise is also displayed magnified, it may be useful to filter the measuring results for a better interpretation. As you have seen, this small function improves the interpretation of the part behavior in such tests. See you next time.